We're looking at the heart of these galactic powerhouses and how we're constantly, refining our map of the universe. Our source is a new report just out today, August 19th, 2025, on phys.org by Tomasz Norakowski, and it details this incredible discovery of dozens of super bright objects, really, really far away.
Yeah, and what's so fascinating here is how these findings from astronomers led by Uni Choi are really pushing our understanding,
Wow.
especially about supermassive black holes and what the early universe was like. So our mission today really is to shed some light on what these things are, these luminous cosmic engines, and how this new study actually found them and why finding them is actually pretty significant.
Okay, so the focus is on quasars, these incredibly powerful beacons, right? Illuminating the early universe. Now, for listeners who might already know a bit about active galactic nuclei, maybe just quickly remind us what makes quasars so, well, unique and relevant here.
Absolutely. So quasars, quasi-stellar objects, they're basically the superluminous centers of active galaxies, and they're powered by supermassive black holes. We're talking millions, sometimes billions of times the mass of our sun. And these black holes are just furiously pulling in matter, accreting it.
Okay.
And that whole process makes them unbelievably bright. They're pumping out radiation across, well, the entire electromagnetic spectrum. Just to give you a scale, like the energy output is over 1 quattuordecillion erg per second.
Whoa, 1 quattuordecillion.
Yeah, it's a mind-boggling number. It's like thousands of entire galaxies worth of light, all coming from a region not much bigger than our solar system.
That's just hard to even grasp.
Yeah.
So given that sheer power, how did this team, the AllBRICQS team, actually manage to find these specific new ones out of everything else up there?
Right. Well, this is where the All Sky Bright Complete Quasar Survey, AllBRICS for short, really comes into play. Its main goal was to track down these optically bright quasars that somehow slipped through the cracks in previous surveys. And the really clever part was how they did it. They used data from the Wide Field Infrared Survey Explorer, that's WISE-IT's catalog. And then they combine that infrared data with super precise positional measurements from Gaia Data Release 3, DR3.
Okay, so combining infrared brightness with pinpoint locations, like a cosmic filter.
Exactly. That combination let them sort of zero in on potential quasar candidates much more effectively.
Was that tricky? I mean, integrating those huge data sets or telling quasars apart from, I don't know, really bright stars or something?
Oh, it's always a challenge with big data, definitely. But their method turned out to be really robust. I mean, the AllBRICQS project had already confirmed 156 quasars before this, and this new report, it adds another 62 to that list.
62 more. Wow.
Yeah, and crucially, every single one of these 62 new finds was then confirmed. They used spectroscopic observations, did that using 3 different ground-based telescopes in South Korea and China, just to be absolutely sure.
So proper confirmation. Now, among those 62, were there any that really jumped out? Anything particularly surprising?
Oh, for sure. I mean, first off, these new quasars are, generally speaking, exceptionally bright compared to your average quasar. Their redshifts, which tell us how far away they are and how much the universe has expanded, range from about 0.09 up to 2.48.
But covering a fair bit of cosmic time.
Exactly. And their total energy output, the bolometric luminosity, is somewhere between 1 and 1,000 quattuordecillion erg per second. So yeah, really luminous. But one really interesting case is J0919 plus 3557.
Okay.
It was initially cataloged as just a galaxy relatively nearby at a redshift of 0.18, but the new observations confirmed it's actually a weak-line quasar much, much further away. Its real redshift is 2.36.
Wow, so a complete reclassification. That's quite a change. Any other standouts?
Yes, definitely. J1356 plus 3840. This one's special. It's classified as a rare typed an iron low ionization broad absorption line quasar, or philobal for short.
Philobal. Okay, what makes that rare or important?
Yeah. Well, these phellables show specific signatures in their light, these broad absorption lines caused by iron ions in powerful winds blowing out from the quasar. And this particular one, J1356 plus 3840, is now the most luminous phellable ever discovered.
The most luminous of its type. Why does that matter?
Because those outflowing winds in fellables, they're a key part of what we call feedback. It's how the central black hole can actually influence the entire galaxy around it, maybe even shutting down star formation. Studying the most luminous one gives us a look at this process in its most extreme form.
Okay, so understanding these outflows is crucial for understanding how galaxies evolve. It's not just about the black hole itself.
Precisely, which leads us to the bigger picture significance.
Right, so beyond just finding these cool, bright objects, what's the real impact? Why does adding these 62 quasars to the list matter for, us trying to understand the universe?
Well, these confirmed AllBRICQS quasars, they're basically a treasure trove. a valuable resource for future studies. They give us fantastic targets for digging into quasar physics itself, understanding how these supermassive black holes grow so big so fast, and as we mentioned, those feedback processes, how the quasar energy affects the host galaxy.
Hmm.
Studying these bright examples, especially across different wavelengths, helps us piece together how host galaxies form and evolve over billions of years. If you connect it all up, looking at these distant objects is like looking back in time. It gives us vital clues about the history of galaxy formation, including galaxies like our own Milky Way.
It really is amazing. Just adding, a few dozen new data points can significantly sharpen our view of these incredibly powerful distant engines in the universe, really refining that cosmic map.
Absolutely. And it kind of leaves you wondering, doesn't it? It raises this important question. What other kinds of extreme phenomena, things we haven't even conceived of yet, might be out there, just waiting in the cosmic shadows to be found, potentially ready to completely rewrite our understanding of the universe's most fundamental processes?
Exactly. There's always more to find. A good reminder to keep looking up and keep asking questions.